Okay, bus. Class 10. कितनी बात है तुम्हारी? खत्म नहीं होंगी। एक जो बात कर रहा उसको बोल दो तो सबसे पहले लगेगा मैं ऐसे तमाशा मुझे मारो ना, यहाँ तक बात कर रहा है। If you are bad, I am bad. Run! माइक कहाँ है? एक माइक वो लगा हुआ। हेलो, मैथ्स टीचर। मैं प्रोग्राम शुरू कर रहा हूँ। सारे बच्चे रेडी हैं? हाँ वही कर रहा हूँ। बेटा तुम लोग ये सीट खाली करो, मैं आपको बुलवा दूँगा। ठीक है? ये किसका फोन है? इसको
अरेंजमेंट नहीं डिस्टर्ब कर।
रिकॉर्डिंग वाला है वो क्या कर रहा है सेट तो कर गया अरे उसका तो आ ही नहीं रहा है क्या नहीं आ रहा है उसका ये अरे छोड़िए ना उसको घुमा दिया जाएगा ना चलो ठीक है तो छोड़िए तो कोई खबर आ रही है ये देखिए जो घुमाना होता था ये ढीला ये क्या है इस वजह से है ना घुमाता है ये नहीं घूम रहा ना छोड़ देते नहीं इसको तो स्टडी किया है इसको लॉक खोलो ये इसको लॉक खोलो
साइड से यहाँ से साइड पे
नहीं हो रहा है आप क्यों कर रहे हो आप परेशान हो रहे हो तो कह रहे हो नहीं हो रहा नहीं छोड़ दिए जैसे हो रहा होना ठीक है चलो तो पहले करना चाहिए था आपको काम लो आप गार्डन में थोड़ी कर रहे हो वो काम हमें थोड़ी करना करो यार बड़े मुश्किल से लगा था कैमरा ऑन करो हाँ ऑन करो तो तुम शुरू करो काम चलो शुरू करो
Without mathematics, there's nothing you can do. Everything around you is maths. Everything around you is numbers. The above mentioned quote is amongst the most famous, mind-blowing and thrilling quotes given by Shakuntala Devi. Like numbers have life, they're not just symbols on papers, and it's important to approach maths only in a spirit of curiosity and discovery. A very warm morning to our principal ma'am, inspection head ma'am, coordinating ma'am, and respected teachers and my fellow friends. Today, I stand before you to celebrate a subject that shapes our world in many ways we might not always realize, maths. Yes, we are gathered here on this special occasion, National Mathematics Day, to acknowledge the importance of the mathematics in our lives. This day is not just another date on the calendar, but it marks the birth anniversary of brilliant minds. Srinivas is not just about celebrating numbers, it's about the of the subject, solving its puzzles, and appreciating the beauty it adds to our lives. With this, I'd like to call upon the stage our Maths HOD, Manoj sir.
Good morning to all of you. Good morning, respected principal ma'am, Sally ma'am, Roli ma'am. आप सभी को नेशनल मैथमेटिक्स डे की हार्दिक शुभकामनाएं। आज हम सभी एक रोमांचक सफर पर हैं जो संख्याओं की जगह। मैथ्स एक ऐसी भाषा है जो हम सभी को समझाती है और या हमारे साथ कौन से लोग जुड़े हों, यह एक साझा रूप से सोचने का तरीका है जो हमें समस्याओं का सामना करने और उसको सॉल्व करने में मदद करता है। गणित में हर एक संख्या की कहानी होती है और आज हम इन्हीं कहानियों को सुनेंगे। संख्याओं का जादू, रैखिकता का सौंदर्य और गणितीय राशियों का समाधान। इस नेशनल मैथमेटिक्स डे पर हम सभी को यह याद दिलाएंगे कि हर व्यक्ति के मन में एक गणितीय जीवन है जो हमें रूबरू कराता है और हमें बेहतर बनाता है। मैथमेटिक्स gives us hope that every problem have a solution. Thank you.
Zero is a strange number and one of the greatest paradoxes of human thought. It means both everything and nothing. It's a number and a numerical digit used to represent that numbers in numerals. It fulfills a central role in mathematics as the additive identity of the integers. Without the invention of zero, the binary system and the computer are not possible. It is the greatest invention on which every calculation depends. Zero is a tiny number, but it can never be ignored. And now we present a slideshow on the song Zero Diya Mere Bharat.
Good morning. Good morning.
Yes, you're audible, sir. You're audible.
Good morning, everyone. Good morning, everyone. Today we are celebrating National Mathematics Day. I am going to tell you about Srinivas Ramanujan. Srinivas Ramanujan was an Indian mathematician born on December 22, 1887 in Europe, Madras Presidency. Despite lacking formal training in mathematics, Ramanujan made significant contribution to the field, especially in number theory, mathematical analysis, and infinite series. Some of his notable achievements include formulating the Ramanujan prime, discovering various infinite series and identities, and making contribution to the elliptic functions. Ramanujan's work led to advancements in areas like mock theta function and modular forms. In 1913, Ramanujan independently wrote to renowned British mathematician G.H. Hardy, who recognized his exceptional talent and brought him to the Cambridge University. Ramanujan collaborated with Hardy and others, producing groundbreaking mathematical results. He was elected a fellow of the Royal Society in 1918. Unfortunately, Ramanujan's life was cut short. He died on April 26, 1920, at the age of 32. His notebooks containing wealth of mathematical discoveries continue to be studied and have influenced various branches of mathematics. Ramanujan's legacy endures as one of the most enigmatic and brilliant
stage Zara and Yash to enlighten us with the word and thought of the day.
Good morning everyone. Today's word of the day is heaps. A large number or amount. I repeat my word. Heaps. A large number or amount. Thank you and have a nice day. Good morning everyone. Today's thought of the day is mathematics is the art of using the same method differently. I repeat my thought. Mathematics is the art of using the same method differently. Thank you and have a nice day.
चांद पे पहुंचे उनके सामने दुनिया ने सर झुकाया हीरो दिया मेरे भारत ने मेरे भारत ने दुनिया को तब गिनती आई तारों की भाषा भारत ने दुनिया को पहले सिखलाई देखा न चलो भारत को चलते जाना मुश्किल था धरती और चांद की दूरी का अंदाजा लगाना मुश्किल था सभ्यता जहाँ पहले आई सभ्यता जहाँ पहले आई पहले जन्म है जहाँ पे करा अपना भारत वो भारत है जिसके पीछे संसार चला और आगे बढ़ा यूं आगे बढ़ता ही गया
Now we will be showcasing a documentary on Srinivas Ramanujan.
Atlanta, Georgia, December 2012. After years of work, mathematician David Bowman and two of his former students come up with a groundbreaking mathematical formula that will allow scientists to study black holes in an entirely new way. Incredibly, they achieved this feat by studying a single paragraph written by an Indian mathematician over 9 decades earlier. Srinivasan Ramanujan. Srinivasan Ramanujan was an Indian mathematician who was unlike any other genius in the world history. Ramanujan's work has now formed the basis for superstring theory and multidimensional physics. Some of the most advanced math that all the high-end scientists are still using today is called modular functions, which could lead to time travel, anti-gravity, limitless free energy, all of this futuristic technology. He was able to take a level that he knew farther than most mathematicians to be able to take them. He had the vision to see what was important. There are just so many beautiful ideas that he had, some of which are just waiting to be developed. Ramanujan made breakthroughs in integral calculus, which can be used to determine the drag force buffeting of wind as it slides through the air or the gravitational effects of the Earth on the man-made satellite. But perhaps what is most noteworthy is that Ramanujan insisted these baffling theorems were not simply the product of his own genius. He claimed they were communicated to him by any other worldly being. Srinivasan Ramanujan was born in Erode, India on December 22, 1887 and was considered a miracle child because he was the only one of his mother's 4 children who survived infancy. Even as a young boy, he was obsessed with numbers. From a very early age, just instinctively, he was thinking about numbers. He was calculating. He was fascinated by numbers. Numbers, he said, had personalities for him, that they had a kind of life for him. There are a lot of stories about how he was so focused on mathematics that he would ignore a lot of his other subjects. Ramanujan grew up in a town of Kumbakonam in a house with view of an impressive Saranfani temple. The mathematical prodigy spent much of his childhood at the temple among thousands of carvings of Hindu gods. According to Ramanujan's childhood friend, he would often go to the temple and work on mathematics. His friend had a memory of coming into the temple and finding Ramanujan with all these inexplicable figures surrounding him. The figures that surrounded Ramanujan were, in fact, complex mathematical equations that he had been put in chalk on the stone slabs of the temple floor. He would often say they were communicated to him in his dreams by the Hindu goddess Namagiri Iyer. He always insisted, and he was very adamant about that his mathematical discoveries he made came to him in dreams and visions provided by the goddess Namagiri. In these visions, he would see these fantastic, beautiful mathematical formulae unfolding before him. Numerous times throughout Ramanujan's youth, he would abruptly vanish for days at a time, then return home without explanation. His neighbors felt suspicious, and he suggested that numbers connect us to higher powers in the universe. Could it be that Ramanujan really was receiving information from an otherworldly being?
Now, to showcase the idea that maths can be interesting, inculcative, and harmonious, I'd like to call upon the stage the students of grade 1st, 2nd, and 3rd to present an action song performance.
Good morning, everyone. We are the students of class 1, 2, and 3. Today we are going to present an action song. Maths is magic. Maths is magic. Learning maths is fun. Learning maths is fun. Maths is queen of sciences. Maths is queen of sciences. Maths is always true. Maths is always true. Addition, subtraction, addition, subtraction, multiplication, multiplication, and division, interesting topics, interesting topics. Math is very interesting, math is very interesting, math is very exciting, math is very exciting. I love math, let's learn with joy. I love math, let's learn with joy. I love math, let's learn with joy. Happy National Mathematics Day!
That was indeed a very educating and cute performance. Now, I'd like to call upon Akshat and Snigdha of class 10 and 12 respectively to present their speech on maths history.
In the Indian subcontinent, the excavations of Harappa and Mohenjo-daro, etc. show that the Indus Valley civilization, about 3000 BCE, made extensive use of geometry. It was a highly organized society. The cities were highly developed and very well planned. For example, the roads were parallel to each other and there was an underground drainage system. The houses had many rooms of different types. This shows that the town dwellers were skilled and in insulation and practical arithmetic. The bricks used for construction were clean fire and the ratio length breadth thickness was found to be 4:2:1.
प्राचीन भारत में शिल्पाशूद्र ज्यामिति रचनाओं के लिए महत्वपूर्ण थे। वैदिक काल की ज्यामिति का उद्गम वैदिक पूजा के लिए आवश्यक भिन्न प्रकारों की वेदियों और अग्निकुंडों के निर्माण काल से हुआ। पवित्र अग्नियों को अधिक प्रभावशाली साधक होने के लिए उनके स्थान, उनके आकारों और क्षेत्रफलों के बारे में स्पष्ट रूप से निर्धारित अनुदेशों के अनुसार हुआ। घरेलू धार्मिक क्रियाओं के लिए वर्गाकार और वृत्ताकार वेदियों का प्रयोग किया जाता था, जबकि सार्वजनिक पूजा स्थलों के लिए आयतों, त्रिभुजों और समलंबों के संयोजनों से बने आकारों का प्रयोग आवश्यक होता था। श्रीयंत्र में एक दूसरे के साथ जुड़े 9 समविबाहु त्रिभुज अंतर्निहित हैं। यह त्रिभुज इस प्रकार व्यवस्थित किए गए हैं कि इनसे 43 छोटे त्रिभुजों का निर्माण होता है। यद्यपि वेदियों की रचना करने से परिशुद्ध ज्यामितीय विधियों का उपयोग किया गया था, फिर भी इनसे संबंधित सिद्धांतों की कोई चर्चा नहीं की गई।
These examples show that the geometry was being developed and applied everywhere in the world. But this was happening in an unsymmetric manner. What is interesting about this development of geometry in the ancient world is that they were passed from one generation to the next, either orally or through palm leaf messages, or by other ways. Also, we find that in some civilizations like Babylonia, geometry remained a very practical-oriented discipline, as was the case in India and Rome. The geometry developed by Egyptians mainly consisted of statements of results. There were no general rules of the procedure. In fact, Babylonians and Egyptians used geometry mostly for practical purposes and did very little to develop it as a symmetric science. But in civilizations like Greece, the emphasis was on reasoning behind why certain constructions worked. The Greeks were interested in establishing the truth of the statements they discovered using deductive reasoning.
एक यूनानी गणितज्ञ थेल्स को श्रेय जाता है कि उन्होंने सबसे पहली ज्ञात उत्पत्ति प्रदान की। यह उत्पत्ति इस कथन की थी कि जब वृत्त का व्यास वृत्त को 2 बराबर भागों में विभाजित करता है। थेल्स का एक सबसे प्रसिद्ध शिष्य पाइथागोरस में था, जिसका नाम आपने अवश्य सुना होगा। पाइथागोरस और पाइथागोरस और उसके साथियों ने अनेक ज्यामितीय गुणों की खोज की और ज्यामिति के सिद्धांतों को अत्यधिक विकास किया। यह प्रक्रिया 300 ईसाई पूर्व तक जारी रही। इसी समय मिस्र में अलेक्जेंड्रिया के एक गणित शिक्षक यूक्लिड ने उस समय की ज्ञात गणित को सभी ज्ञान को एकत्रित किया और एलिमेंट्स नामक अपने प्रसिद्ध ग्रंथ के रूप में उसे उपस्थित व्यवस्थित किया। उन्होंने एलिमेंट्स को 13 अध्यायों में विभाजित किया, जिनमें से प्रत्येक को पुस्तिका माना जाता है। इन पुस्तिकाओं ने समस्त विश्व को ज्यामिति संबंधी समझ को आने वाली पीढ़ियों तक प्रभावित किया। धन्यवाद।
I'd like to call upon Dhyan and Ayush of class 8 to present a presentation on magic square.
मैथ्स में डब्बा गुल, मैथ्स में डब्बा गुल, मैथ्स में डब्बा गुल, मैथ्स में डब्बा गुल, मैथ्स में डब्बा गुल। क्या मैथ्स में डब्बा गुल? Do you know that maths can be an interesting and exciting subject? I don't understand how one could be comfortable with all the numbers. मेरा तो सर घूम जाता है. What if I tell you about a magic square? Not another one. I am sick of these squares. But ये वाला अलग है. This was formulated by Ramanujan. Do you see that square? It has 4 rows and 4 columns. If you add the numbers in a row, then the sum of the numbers is equals to 139. Similarly, if you add the numbers in a column, then also the sum will be 139. And if you add the numbers diagonally, then the sum of the numbers will be 139. If you add the corner elements, then also the sum of the numbers will be 139. If you add these two, these and these two or these 4s, then also the sum will be 139. If you add the center squares, then the sum of the numbers will be 139. तो इसमें स्पेशल क्या है? Do you see that first row? It's Ramanujan's birthday. If you combine 18 and 87, it becomes 22 December 1887. It's the birth date of Ramanujan. Because the sum of the birth date is equals to 139, therefore in all the combinations it is 139. Do you mean that I can do it for my birthday? Yes, you just have to use this formula. For example, if the birth date is 30th August 2005, then let A be 30, B be 8, C be 20 and D be 5. Then you just have to use this formula to fill up the square. Put the values of A, B, C and D to fill the square. After you fill the square, your magic square will be ready. See, your own magic square is ready, in which the sum of the columns, rows and the diagonals will be 63, because the sum of the birth date is equals to 63. I didn't know math could be fun as well. I am surely going to try this for my birthday. Thank you.
Now I'd like to call upon Purvi of class 9 to enlighten us with the history of quadratic equation.
Good afternoon, everyone. I am Purvi from class 9. I am here to tell you the history of quadratic equations. Many people believe that Babylonians were the first to solve the quadratic equation. For instance, we जानते थे कि कैसे दो numbers को find किया जाए, इसका sum और product दिया हुआ है. And this problem was equivalent for solving the quadratic equation. After this, a Greek mathematician, Euclid, developed a geometrical approach for finding out the length, which, in our present, terminology are solutions of quadratic equations. But solving of quadratic equations are often credited to ancient Indian mathematicians. In fact, Brahma gave an explicit formula to solve the quadratic equation. बाद में श्रीधराचार्य ने एक डेरिवेशन किया जिसे अब हम क्वाड्रेटिक फॉर्मूला के नाम से जानते हैं और ये डिस्क्रिमिनेंट रूल के नाम से भी जाना जाता है क्योंकि ब्रिटिश श्रीधराचार्य का नाम प्रोनाउंस नहीं कर पाते थे तो वो उसे डिस्क्रिमिनेंट रूल के नाम से बुलाते थे एंड क्वाड्रेटिक फॉर्मूला इज अ मेथड ऑफ सॉल्विंग क्वाड्रेटिक इक्वेशन बाय कंप्लीटिंग द स्क्वायर. After this, an Arab mathematician, Al-Khwarizmi, also studied about the different types of quadratic equations. In AD 1145, Abraham Al-Hanafi gave a complete solution in his book Liber in Vibram, which was published in Europe. Thank you and have a nice day.
I'd like to call upon Shrishti Mishra of class 9 to enlighten us with Sri Yantra.
Good afternoon, everyone. My name is Shrishti Mishra. I am from class 9. Today, I am going to tell you about Sri Yant. The Sri Yant, a sacred geometric pattern, is a symbol in Hindu and Tantric traditions. It consists of interlocking triangles and a central point representing the cosmos and the divine feminine energy. Used in meditation, it is believed to bring spiritual and material will. The intricate design embodies profound spiritual meanings reflecting the interconnectedness of the universe. Mathematically, the Sri Yant is fascinating due to its precise geometric construction. It involves complex mathematical principles including sacred geometry and the Fibonacci sequence. The triangular patterns, when studied mathematically, reveal intricate relationships and proportions that are believed to have deep spiritual significance. The Sri Yant is often considered a visual representation of the cosmic order, and its mathematical precision is thought to reflect the harmony and structure inherent in the universe. Thank you and have a nice day.
Now, I'd like to call upon the students of class 4th, 5th and 6th to present a geometric mathematical dance.
Keep going.
Hello,
And I'd like to call upon stage Prisha of class 11 to show that bio and maths can be fused to give fruitful results. That is, the integration of mathematics in biology.
Good afternoon, everyone. I, Prisha Singh of grade 11, would like to discuss about the integration of mathematics with biology. Mathematics play a key role in many disciplines of science, primarily as a mathematical modeling tool. New innovations and development in physics are by the influence of mathematics. Calculus was invented entirely for the use of physics. The important role of mathematics in physics is understood by the existing disciplines, mathematical physics or theoretical physics. One can think is mathematics has the same important role or even lesser important role in the field of biology, and is mathematics and biology could possibly have anything in common. Even though physics and biology are very different sciences, mathematicians and biologists develop the mathematical biology or biomathematics. As a recent discipline for the mathematical representation in biology to the theoretical and practical applications in biology, biomedical, and biotechnical researches. Mathematical plays a crucial role in various aspects of biology. It is used for modeling biological process, analyzing experimental data, and making predictions, from population dynamics to genetics. Mathematical tools help biologists quantify relationships, describe patterns, and formulate hypotheses. For example, mathematical models are employed to simulate the spread of diseases, understand population growth, and predict genetic inheritance patterns. In essence, the integration of mathematics and biology, often known as mathematical biology, enhances our understanding of complex biological phenomena. Thank you.
Now I'd like to call upon the stage Shan Pratap Singh of class 11 to present a magic trick.
Good morning everyone, my name is Ishan Pratap Singh of class 11. So today I am here to show you some math tricks. So generally there are many tricks by which we can calculate your house number, phone number, etc. But today I will be calculating your age by using the help of calculator. So for that I would like to call Abhishek sir. First of all, good afternoon, sir. Sir, so you are carrying a phone with you? Yeah. Sir, so please open the calculator. So first you just think about your age and multiply it by 7.
Age multiplied by
7. What is it? So now you multiply it by 143.
143.
Yes, sir. What's it?
3 2 3 2 3 2 3 2.
So what's the answer? 3 2 3 2 3 2. Trying to be observed. Age will of mistakes is 30.
Great magic.
Anyone else? I would like to call Sachin sir. What do you? Let's say, firstly, you think about your age and multiply by 7. Then multiply by 1443.
1443.
Yes, sir. What is coming?
27 27 27.
So, is it your 27?
Yes.
Very good. That's Next time I'll show you some other things. Thank you.
And I'd like to call upon stage the Bill of Class 9 to enlighten us with Shulba Sutra.
Good afternoon, Good afternoon, everyone. I am Dimple of class 9 and today I am going to tell you about Sulba Sutra. The Sulba Sutras are the Sutra texts belonging to the Swata ritual and containing geometry related to fire altar construction. The Sulba Sutras are a part of larger corpus of texts called the Swata Sutras and considered to be the appendices to the Vedas. They are the only source of Indian mathematics from the Vedic period. They are considered or gifts from the god. The sutras contain statements of Pythagoras' theorem, both in the case of an isosceles right triangle and in general case. They also contain Pythagorean triplets. The four major Sulba Sutras, which are mathematically the most significant, are those attributed to Baudhyana, Madhava, Apastamba, and Katyayana. Their language is late Vedic Sanskrit. The oldest is the Sutra attributed to Baudhyana, possibly compiled around 500 BCE to 800 BCE. The Baudhyana Sutras give the construction of geometric shapes like squares and rectangles. The K.S. Krishna mentions that the Sulba Sutras predates Mesopotamian Pythagoras theorem. Swedenborg argues that old Babylonia got the theorem of Pythagoras from India, or either old Babylonian and India got it from any third resource. Thank you. Have a nice day.
Now I'd like to call upon stage Anvit and Shwetar of class 7 to enlighten us about the chronology of pi.
Good afternoon, everyone. Today, we're going to be talking about the chronology of pi, unveiling the mysteries of the infinite ratio, the imagination and curiosity of both scholars and enthusiasts as much as the irrational number pi. Represented by the Greek number pi, the enigmatic mathematical constant has woven its way through the fabric of human accomplishments, leaving an indelible mark on the realms of geometry, trigonometry, and calculus. The story of pi is a journey which spans a millennium, traversing cultures, civilizations, and mathematical revolutions. Join us as we embark on captivating exploration of the chronology of pi. Pi was first used by Egyptians who used it by using the formula 4 multiplied by 8 by 9 squared. Afterwards, many other inventors also used pi and found out several other decimal places.
The value of pi has been people have been trying to find the value of pi since 4000 BC. Many people, such as the ancient Egyptians, ancient Babylonians, have tried to find value in pi, but they have come really close. Like a Chinese mathematician, Louis in 14th century, found 3 decimal places of pi. After him, many people like Aryabhatta and Srivastava, Ramanujan, and many people tried to find the value of pi, but they could not. So the value of pi, so the exact value of pi still remains a mystery. The pi is still an irrational number that is used to find the area and circumference of a circle.
Pi was first found by the supercomputer ENIAC in 1949, where ENIAC found 2,000 decimal places in 70 hours. This might seem small, but at that time this was quite a big accomplishment. Currently, the world record for the most decimal places of pi found is 100 trillion decimal places. Now, this might seem as a surprise to you because 100 trillion is quite a lot of decimal places, but this is still not that. In the future, people aim to get many more than future. So, in developing a trivial, we embark on an odyssey through the epochs of human history and civilization, uncovering the captivating narrative of this mathematical constant. Across the sands of time, pi has left its indelible mark on human history, connecting cultures, minds, people, and mathematical landscapes. Our journey began from the ancient Egyptians and Babylonians with a fundamental challenge of measuring sleep circles. Archimedes in the classical era has now even made our life more illuminated with the help of this invention. Beyond its mathematical significance, pi is also used in other languages like Greek. So, in our conclusion reflections, we find pi more than a numeric constant, but instead a testament for humans' relentless pursuit of understanding. Thank you all for listening.
I'd like to call upon Shikha Rai of class 11 to show a magic. So that's me. My volunteers, Ishan, Risha, totally random. Okay, now I'm gonna need a volunteer amongst the crowd. Maybe the teachers, teachers. Anyone willing to volunteer?
Vastavi is there. You can call it.
Vastavi. I'm actually it's gonna be calculation part, so I need a teacher. Abhishek sir, kindly come in. Okay. He's not aware what's going to happen. They are not aware what's going to happen. I just told them कि आपको आना है. You are going to be voting. So you can write a number. It's National Mathematics Day. You have to write 10 digit, 5 digit, single digit. Just write a number. Hide it from everyone. Write it, fold it, and keep it safe. I'm going to need a number. A fresh piece of paper. Prisha, could you kindly help me here? I'm going to ask you to write your birthday on the paper, clean and clear. Done. Now I'm going to write you a very important day of your life, like your board results, or when you got married, etc. etc. Anyone who got married, important day of your life. Now, you've written that. Now I'm going to ask you to subtract 2007, your birth year, from 2023, and write the answer over here. So now I'm going to ask you to subtract 2019 from 2023. Again, done? I'm going to ask you to write it in order, like 2007, 19, 16, and 4. Very good. Excellent. Now I'm going to ask you to add them.
Okay, so that's the number that you got. It's 4046. What's the number over there, boy? 4046. Thank you so much. You see, I was the charming anchor. Now you can call me the charming magician. I don't care. Just call me something. Thank you very much. Thank you so much.
I'm gonna ask Roli ma'am to come on the podium and say a few words.
That was really awesome, Shikhar. I want to learn. Alright?
Yes, ma'am.
Yes, and how was this all mathematical day? Did you enjoy it? Yes! It was too informative, no? Too knowledgeable. Sulabh Shastra, God knows what is that. And Sri Yantra, it was so informative. No? Okay, so can you tell me, when was Ramanujan born?
22nd December.
Yes, tell me.
22nd December.
22nd December. Every year he is born on 22nd December.
22nd December 1887.
That's good, yes. So mathematical day is celebrated on 22nd December and he was born on 22nd December 1887. You should know. Okay, he was known as Miracle Child. Can you tell me why? There was a documentary on that. Let me see how many of you were attentive. He was known as Miracle Child. No one. I know you people were distracted, disturbed.
Ma'am, because he was the only one who survived among his four siblings.
Wonderful, excellent, very good. So he has given a lot of mathematical concept infinity series, which is the most famous one. And your math teachers will tell you what is infinity series. Even I don't have much idea on it. Okay. Now, can anybody name 5 great Indian mathematicians? In one go, you have to say. Let me see. How many have seen the video? How many heard the speeches? 5 in one go. Okay, 3 in one go. Yes.
Ma'am,
Just raise your hand, I can understand.
Mr. Ramanujan,
Mr. Ramanujan.
Mr. Shakuntala Devi,
Wonderful.
and Mr. Anand Kumar.
Anand Kumar. Wow, that's great. Good job. Anyone else? Other than this. You don't have to repeat the mathematician. Sridharacharya and Bhaskaracharya, Aryabhatta. You should know all these names. Alright, so we are talking about Ramanujan so much. So let's see, there is a park dedicated to Ramanujan in Andhra Pradesh, Kottam. Let's see. No sound? No problem, it's okay, I will speak. So see, this is spread on vast area in Andhra Pradesh, Kottam. And August Campus Creativity Lab means August are a community which is taking care of. This is Infinity Gate. Sorry, Pi Gate, from where you have to enter into this maths park. This this is Sri Ramanujan, Srinivas Ramanujan, our mathematician, genius. So these are all interactive geometrical shapes. Can you see circle, diameter? This is Pythagoras explained. I don't know what they are doing here. This is fraction slab. See, they are learning. Hands-on experience you get here. So you will find indoor as well as outdoor mathematical activities, indoor games related to maths. This is what? Okay. Now see interactive panels. Can you see symmetry and various patterns? No one? Alright. So stop, pause. So you can ready with the next video. Okay, so if you go to Andhra Pradesh ever, don't miss this. Okay, now Shikhar has shown you one trick. I will also perform this teaching you well. So hats off to your math teachers. And you know my favorite subject is also maths. And now I am going to check your maths calculation, mental maths. So be alert. This is simple addition and multiplication. Okay? So think of a number. And I would suggest think of any small number so that you can add and multiply easily. Any simple number, thought? Yes, multiply by 2. Yes, add 2. Yes, multiply by 5. Yes, add 5. Yes, multiply by 10. Yes, add 10. Yes, now one by one you will tell me the answer and I'll tell you what is your number. One by one, okay? Yes. 360, you took 2. Your number was 2. Yes. 260, you took 1. 0. You have taken 0. 660. You took 5. Yes. 1? 261. You have taken. You don't tell. You just tell me the answer. I'll tell you the number you have taken. The calculation is wrong. Your calculation is wrong. Yes. 360 you took 2. Calculation is wrong. 660. Huh? 660. 660. You took 5. You took 5. You 360. You took 2. Now, did you understand how did I get? What is the trick there? You did not get. Okay, I will teach you something. Right now, I am not telling you. Yes, you. What is your number? What answer did you get? Wrong calculation. What? 140 wrong calculation. Ashish? 260. Took 1. You took 6. You took 5. 760. You took 6. Okay, wonderful. Very good. You have wonderful maths calculation. I like it. Now, one trick you will learn from me, that is basic tricks. And I will ask. So you have to see here and see these are, you should learn basic tricks so that you can do mathematical calculation quickly. These basic tricks are very useful for your competition. Alright? So let's see who will understand.
Hello everyone. Today I will teach teach you how to multiply any two-digit number by 11 mentally. These tricks are known as Vedic maths tricks. And do you know Shakuntala Devi was outstanding in these tricks, and that's why she is also known as human computer? Hope you have all seen her movie starring Vidya Balan. Right, so let's begin. So these are some of the numbers which needs to be multiplied by 11. The trick is very, very simple. It's like magic. So what you do, you just have to write these two numbers, 5 and 2 as it is. Please.
Or can you calculate in seconds? Not me. Anyone else? You can calculate in seconds. I can calculate all this in seconds. You can? You want to try? Yes? Try? You want to try? Okay.
I think the first answer is 572.
Wonderful. Second one. You are taking time.
65.
275.
275. Very good. Very good. Yes. Yes.
693. 693.
693. Very good.
594.
594. Wonderful. Very good.
894.
Wow. So if you know this trick, can you explain me how it is done? Only 4 to 5 children know. I want everybody to know this trick. This is the easiest Vedic maths trick. Who can explain? Anybody want? You want to explain? Okay.
In the last line, 11 multiplied by 81, we have to add 8 plus 1, then it's the 9, and we put 8 and 9 in the middle.
Very
8, 9,
good. Clap up. That was clear. Alright? How many did not understand? How many of you did not understand? Because I will ask everyone. No problem. If you don't understand, no problem. It's okay. You don't. Okay. So I will play the video. Let's see how it is done. Okay?
Period space in between, and then add the same numbers 5 plus 2 is 7 in circular. Simple, right? So again the same thing, 2 and 5 you can correct, and then add these two numbers 5 plus 7, that will be inserted in the middle. So now you can do mentally, right? So 6, 3 is 9. So 6, 9, 3. 11 into 54, 5, 9, 4. 11 into 81, 9, 1. 11 into 72, 7, 9, 2. Excellent. Now let us.
Okay, so I think everybody understood. Pastor, you understood? Alright. 11 into 22. Vastavi, everybody is Vastavi. Yes, Vastavi. Excellent. Ayansh, right? Aryan. Okay, 11 into 51.
5, 16, 5.
565. This is the way to speak. I don't think any teacher is teaching you like this to speak. Is anybody teaching you to speak like this? No? Then what is the decent way? What is the decent way? Just raise your hand, I will understand. Okay? So 11 into 34. Very good. 11 into 36. 11 into 36. 396. Is it written there? No. 11 into 31. 341. 11 into 11. Single or Excellia? 1 Yes. 11 into 42.
Okay, good job.
I'd like to call upon our respected director ma'am to enlighten her with the words of wisdom.
Good afternoon, everyone. So, students, what you learned today? It was very informative, very knowledgeable session with you on this day. I want to share one story with you. Uh, my maths teacher was Mr. Naseem when I was in class 5th. One day, he was having one conversation with us. At that day, he told me about uh, Mrs. Shakuntala Devi. Do you know about who was she? What she was doing in her childhood? She belonged to a acrobatic family, you know that? Yes, tell me.
Acrobat is basically sort of a gymnast, but and all in circuses.
Yes, वो रस्सी पे जो चलते हैं ना बच्चे, okay? She was actually performing that kind of art in her days because she was from very poor family. So, what is the message I want to give you? If she can achieve that kind of knowledge, you can also do that. Okay? First, what you have to do? What you have to do, tell me? One thing. Another thing?
Ma'am, hard work, focus, concentration,
And tell me. You have so much words to say. You have so much to say. Okay. You all know. Everybody knows what. Okay? आपको क्या करना है? ठीक है? So what will you do now next? Tell me. I just want that answer from your side. शकुंतला देवी ने जैसे ही नंबर्स को काउंट करना शुरू किया, एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, उसमें क्या किया? हिंदी में एक वर्ड है महारत हासिल कर लेना। आप जो भी करो, whatever you are doing, उसमें परफेक्शन ले आओ, ठीक है? करते आज वो इस जगह तक पहुंचे कि हम उन्हें याद करें। टुडे वी आर रिमेम्बरिंग हर। सो यू वांट दैट कि हमें भी लोग याद करें, आपको भी लोग याद करें। ओके, तो आपने अपना आंसर खुद ही दिया कि हमें क्या करना है। So now you have to focus. You have to listen to your teachers, understand what they are saying. Okay, and behave properly. That is the most important thing you have to do. Thank you very much, Bachcho. It was a wonderful experience.
Thank you, ma'am. I'd like to call upon our respected principal ma'am to share her words with me.
Very good afternoon to all. I hope you all have enjoyed whatever the activities they all have presented, no? Yes, ma'am. So today we are having this presentation, we are celebrating his birth anniversary. Whose? Yes, absolutely, he was a great mathematician, though he did not live long, but yet again, थोड़ी सी जिंदगी में उन्होंने काफी लंबे, काफी बड़े काम किए, right?
But a short brief of time that I got in front of you all, I'm going to highlight some of the key aspects of mathematics. Mathematics, even I like mathematics a lot. And why? Let me tell you. The firstly, why I like mathematics and what are the key aspects. One of the aspects of mathematics that it's universal. It transcends all the boundaries, all the languages. It doesn't matter wherever you are or wherever you go. You're in India, you're in USA, you're in Europe. Wherever you go, the principles of mathematics always the same. It's always same. It's a universal language. Everybody understands. Now, secondly, why do I like mathematics? Another key feature of it, that it's a problem solver. It equips you with the tool and the knowledge to analyze the situation, to stabilize the situation, to quantify it. Various wide range of problems are there, you can easily solve them. Be it calculating the trajectory of a rocket, diseases that has spread. The last 2 years we got to know about some dread disease, no? That was coronavirus. Everything, even managing your finances, we can do if we know how to equip ourselves, how to analyze all this thing, and it all happens because of the mathematics, aptitude and the skill that we have. And thirdly, absolutely not the last one, that it's beautiful. Why is it that? Did you see the pattern of nature? It's mathematics. Do you see the symmetry of snowflakes? Mathematics. Numbers are almost everywhere. As the charming anchor come student, come magician has stated, that the one fact that we cannot ignore, that numbers are everywhere. Even when we started this session, do you know what all we have to go through? We have to see how many classes having smart boards. We have to see how many students we could accommodate in the dimension of this room. We have to see lot many things, how to arrange this thing, what should be the pattern, where should be the length, how much the distance is required. Numbers are everywhere. Mathematics is beautiful. It helps you to unravel the mystery of the universe. It lets you know that world is beautiful and it is filled with numbers. We are here and there. Numbers are everywhere. I hope you understand what I'm trying to say. So let's enjoy mathematics. And to enjoy the mathematics, you have to love the subject. बहुत boring है, डब्बा बोल and all that. I don't believe in all that. Let me tell you. If you fall in love with subject, you're going to love it, you're going to enjoy it. और कोई ऐसा काम नहीं अगर आप चाहें तो हो नहीं सकता. अगर आप चाहेंगे तो होके ही रहेगा. And there are n number of examples inside outside. Even your teachers, look at your teachers. They only thought of it and you could see it is happening here in front of you in such a short span of time, right? So once again, thank you to the convener, all the teachers in the grade behind it. All the mathematics teachers, Mr. Manoj, Mr. Anup, I think one of the children's favorite teacher, whoever always is called in this part of the state, Mr. Abhishek. Mr. Rahul, all the mathematics, Mr. Sachin, Ruchira ma'am, everyone. I hope I'm not forgetting anyone's name. Ms. Swapnil, Ms. Chaitali, everybody who have participated, to the charming anchor, of course. Thank you so very much for pulling this off. Thank you.
Thank you so much, ma'am. And now I'd like to call upon stage Manoj sir for the vote of thanks.
Thank you. आज बच्चों ने कई इमोशनल कर दिया. रोज जब हम लोग मैथ्स पढ़ाते हैं, आज बच्चों ने कई प्रकार के मैथ्स पढ़ाए, डांस भी किया, बट हम लोग एक ही टाइप के मैथ्स पढ़ाते हैं. सबसे पहले मैं डायरेक्टर बोलूँगा, आपने कीमती समय निकाला और हम लोग को ज्वाइन किया. मैं प्रिंसिपल मैम को थैंक यू बोलूँगा, क्योंकि उन्होंने जिस प्रोग्राम के लिए परमिशन दिया, और एक छोटा सा 5 मिनट का प्रोग्राम होने वाला था, बट आफ्टर डिस्कशन के बाद में मैम ने कहा नहीं, इसको बड़े रूप में करिए, 1 घंटा कम से कम होना चाहिए. और रोली मैम भी थी, तो दोनों की सहमति से ये प्रोग्राम हुआ. और हम सभी लोगों ने एंजॉय किया। मैं इसके बाद में अपने सहयोगी अनूप सर, पुष्पेंद्र मैम, जिन्होंने अपनी खूबसूरत आवाज दिया, हम लोगों ने सुना डॉक्यूमेंट्री में, राहुल सर जिन्होंने बच्चों को ट्रेन किया डांस के लिए, उनको मैं धन्यवाद कहूंगा। और अंत में मैं अपने मैथ्स डिपार्टमेंट के सभी सहयोगियों को थैंक यू बोलूंगा कि उन्होंने कड़ी मेहनत से एक शॉर्ट नोटिस में इतना बढ़िया बच्चों को ट्रेन करके और मैथ में बहुत कुछ सिखाते सिखाते उन लोग को परफॉर्म भी करवाया, डांस भी करवाया और बहुत ही ध्यान से देख करके बच्चों ने एंजॉय भी किया और बहुत कुछ सीखा भी। थैंक यू सो मच। मैम मैं चाहूँगा कि बस एक मसला कि हम सभी जितने भी टीचर्स हैं और आप लोग के साथ एक फोटोग्राफ हो जाए।
How creative way to say that. Yes, literally loved it. You have to pay attention to even the smallest little details that we are presenting over
सॉरी मैम, आपको मैंने इंटरप्ट किया, आप कुछ कहना चाह रहे हैं?
मैंने अपना स्टेटमेंट दे दिया, नो मोर डब्बा गोल इन मैथ। ये आपका शो बना है। ओके,
मैथ के सारे टीचर्स आ जाएं। राहुल सर, अनूप सर, सतीश सर, इनकी टीचर किधर है बुला दीजिए।